Today we're talking about Lesson 2.5, Creating and Solving Compound Inequalities. This is for my Algebra class. The essential question is, how can you solve a compound inequality and graph the solution set? So the first type of compound inequality that we're going to talk about is involving an and statement. So an and statement is the intersection of two inequalities. That's what makes it a compound inequality. It's the overlapping region. So if you look, I want to just talk a little bit about this compound inequality right here. 2 is less than or equal to x, which is less than or equal to 6. One of the reasons I like to talk about it before I start is so that you can understand what makes it a compound inequality. So right here, if you'll notice, this is actually an inequality. X is greater than or equal to 2, written backwards. The other part of the compound inequality is this. X is less than or equal to 6. So there are two parts to it. So if I were to look at this, x is greater than or equal to 2, I have to read that backwards, and I know that my answer is equal to 2 or greater than 2. And this one I read as normal because my variable is first, which is the way it should be. X is less than or equal to 6, so I know my answer is less than 6 or equal to 6. So it's everything in between 2 and 6. So an and statement is the overlap, and it's written as one compound inequality. And this is going to be important when I talk about the or statement. So in order to solve a compound inequality with an and statement, you actually have to solve for the variable that's in the middle. So we have to get the x by itself. We're going to do that by looking at it with the two different inequalities. So here's your first inequality. If you notice, it's 4 is less than or equal to x plus 2. And your second inequality is right here. X plus 2 is less than or equal to 8. So you can separate them if you want, and that's what they did right here. This is one compound inequality, part of it, one part of it. And then here's the second part right here. So if I were to solve this one, I would minus 2 to both sides, and I get 2 is less than or equal to x. Here I do the same thing, minus 2 to both sides, and then I get x is less than or equal to 6. So what you'll notice is that this is actually written backwards. If we read this the correct way, it's actually x, reading it backwards, is greater than or equal to 2. So again, it's x is greater than 2 or equal to it, and less than 6 or equal to it. Now these two graphs right here are just showing the individual inequalities. So x is greater than 2, greater than or equal to 2, going up. X is less than or equal to 6, going down. And again, the answer is the overlap. Notice that it is the in-between is the solution set. Okay, so now I'm going to show an example, and we're going to work through it. So if you look at example B, this one, they're not going to do the inequalities separate. They're going to actually do the inequalities, both inequalities at the same time. So we're going to add opposite, and then we're going to divide, getting our variable by itself. So we first do our add opposite. Now watch this. If I were to do this separately, I would minus 3 to both sides, and I would minus 3 to both sides. But I actually can do it at the same time and minus 3 to this side as well. So that's what these boxes are for. They've minused 3 from the negative 5. They've minused 3 from here. And they've minused 3 from the 9. The result, add opposite, is negative 8. Now notice these are going to cancel, so you get the 2x in the middle, and 9 minus 3 is 6. So then the same thing. Now we've canceled that. Now we have 2x left, see? So we need to get x by itself in the middle so we can solve our inequality and graph it. So we divide by 2. So I divide by 2 here. I have to divide by 2 on the other side of the inequality, as well as this one. So divide by 2. So negative 8 divided by 2 is negative 4. Now these cancel. I have my x in the middle by itself, and 6 divided by 2 is 3. It's definitely 3. So then look, what they're saying is the solution set is between -4 and 3. Now I'm going to show you this down here. I'm going to write this -4. I'll move this up a little bit so you can see it. Is less than or equal to x, which is less than 3. So if you take a look at it, they're writing it separately. They're doing each inequality separately. I'm going to rewrite this so I have my variable first, because you should always have your variable on the left side. So x, reading it backwards, is greater than or equal to -4. So I start at -4. It's a closed circle because it's equal to, and it's x is greater than or equal to -4. Again, if your variable is on the left side, your arrow goes the same way as your inequality. So x is less than 3, so I start at 3, and it's an open circle, oops, right here. And I'm going to the left here. So the solution to -4 is less than or equal to x, which is less than 3, is in between those two. In other words, the overlap. So if you look at the overlap, it's right here. So shortcut, you put a circle at -4. It's closed because of the fact that it's equal to. You put a circle at 3. It's open because it's not equal to, and it's everything in between. Now, I'm going to go back here one more time, and in between is an and statement. So this is an and statement. An and statement means that your solution, generally speaking, comes together. All right, so the next example that we're going to do is an or statement. So I'm going to move to the or statements, which are right here. Now, an or statement is a union. Now, I get confused about that word, and my kids get confused about that word, because a union means, when I think about it, coming together. But a union in this case means it can be this or that. So I'm going to show you x is less than or equal to 2, or x is greater than or equal to 6. So x can be less than or equal to 2. Now less than or equal to 2 would go this way, right? Go to the left. Or x is greater than or equal to 6, so it would be a closed circle and going away from it, greater than or equal to 6. So an or statement or union means it could be this or it could be that. But what you notice is that an or statement, they go away from each other. So that's what an or statement is. Now obviously if it's less than, it's open circle. And that's what this is talking about up here. So I'm going to go to the next page, and I'm going to go through some examples with you. So I'm going to move this down here so you can see it. The first thing I want you to notice about the or statement is they are not written as one inequality. Look, they're written as two separate inequalities. So when you have an or statement, you actually solve them separately. So if you look, they added 4 to both sides. When you add 4 to both sides, add 4, that equals 5, and these cancel. So it's x is greater than 5. Here, this other statement, they added 4 to both sides, and these cancel, and you get x is less than 1. So now our answer is x is greater than 5, which is what they have here. X is less than 1, which is right here. The solution set is this or this. So if I said to you, hey, give me a solution that would work, you could say 0 would work. You could say 6 would work. If I said a non-example, one that wouldn't work, it would be anything in here. These would not work for the solution because it would have to be this or that. Okay, so now how would we solve a problem like that if we were given two inequalities for multiplication? Well, this one is 2x is less than or equal to 6, or 3x is greater than 12. You just solve it like normal. You divide by 2 and divide by 2. So x is less than or equal to 3, or divide by 3, and that's x is greater than 4. So our solution set is x is less than or equal to 3, or x is greater than 4. And now when I graph this, I'm going to show you just how to graph it as your answer. So x is less than or equal to 3, so I go to 3, and I make a circle and I say, is it open or closed? It's closed because it's underlined, equal to, and less than. X is greater than 4, so I go to 4, and it's an open circle, see, because it doesn't have an inequality that is an equal to. So it is greater than 4. That means 4 is not a solution. So now if I said, okay, give me an answer, give me a solution that would work, one number that would work. 1 would work, 2 would work, 3 would work because it's closed circle. 4 would be not a solution. The reason 4 is not a solution is because it's an open circle right there. All right, so now if we look at the two types of problem that you have to do, we are doing or statements like this, and we are doing and statements, which look like this. With an and statement, we'll do one example right here, number 4. You're going to write it as one compound inequality. So you would minus 2, minus 2, minus 2. Negative 10 minus 2 is negative 12. Less than or equal to 3x. These cancel. Less than or equal to 8 minus 2 is 6. Divide by 3, divide by 3. All three expressions. Negative 12 divided by 3 is negative 4. Less than or equal to x, which is less than or equal to 2. How do I graph that? I go to negative 4, I make a circle, it is a closed circle. I go to 2, make a circle, it is a closed circle again, and then it's everything in between because this is an and statement right here. How do I know it's an and statement? Well, first of all, there's no or there, and it's one inequality. It's a compound inequality. I can also look at it and say x is greater than or equal to negative 4, right here, going this way. And x is less than or equal to 2, going this way. So that's my and statement. This is what's expected as your answer. Okay, for my or statement, I can pick either one of these. I'll do the two-step, or well, actually, yeah, the two-step, which is this one right here, number 7. So I'm going to solve them separately. So I add 1 to both sides of my inequality. So I get 4x is less than 16. I divide by 4. X is less than 4. Then I solve over here. Divide by 8. X is greater than or equal to 6. So it's x is less than or equal to 4, or x is greater than or equal to 6. When I graph that over here, I start out x is less than 4. Open circle at 4 because there's no line underneath it, and it's going to the left. It's going to the left because my arrow is going to the left because I have my variable first. X is greater than or equal to negative or to 6. It's a solid circle closed, and it's going to the right. So the next part of this is, now that you know how to graph it, now we're going to do the inverse of that, and that is just writing a compound inequality. So to write a compound inequality, you can see this is an or statement. The reason it's an or statement is because it's going away from each other. So you're going to have one inequality or this other inequality. Always write your variables first when you're doing an or statement. So it's x is, and this is less than or equal to negative 1. Less than or equal to negative 1. This one here is at 7, so it's x is, and we're moving to the right, greater than or equal to 7. So that's how you write that compound inequality. The second example of how to write a compound inequality when given a graph is this type, which is an and statement. It's and because it's in between. So it's starting at 0. with this one, you write the number, and you write your variable in the middle. So 0 and 6. Write your x in the middle. Now look at your inequalities. This is equal to. So it's actually 0 is less than or equal to x, which is less than 6, and this is an open circle. What I want to show you with this is that you're going to want to write this backwards. Kids do it all the time. They write it just like that. And this would obviously be an equal sign. But if I do this, I want you to watch what the solution is. The solution for this is x is greater than or equal to 0, which is true. But then I want you to watch this one. X is greater than 6. Is your solution greater than 6 right here? No. So the thing that I always teach my kids is this. When you're doing a compound inequality, both inequality signs face the left. They both face the left. Because remember, this one is written backwards. So this one should go to the left because it's less than. So, good luck on your homework tonight. That's all I got.